Okay, in this final video, I just want to visualize the problem we did in part 2. Okay, so you can see the numbers that align or that are in the matrix align with the problem that we just did. Okay, so those could all be represented by planes, and all of them have x, y, and z values, so they're not parallel to any of the axes. So it's these 3 planes over here. Remember, red, then green, then blue, representing the 3 rows of equations that are in the matrix, right? Now, if I make it more transparent, you can kind of see how the axes show up in there. Okay, so there is a single point of intersection on the graph at 1, 0, -2. So all of the planes come together. It's actually easier to kind of see that they all come together at a single point. If I make it less transparent, there's a point where the red, green, and blue all come together, and that point is 1 in the x direction, 0 in the y direction. So we're on the y-axis. You can kind of see that it should be right on the green axis, the point of intersection. And let's see. It's -2 in the z direction is where the intersection is. Okay, so there we have it. Okay, so the point of intersection, actually it's not on the y-axis. It's nowhere in the y direction of the y-axis. So if we were to look down from above and kind of eliminate, actually look at it from this direction, we can kind of see that point is 1 in the x direction and 2 below in the z direction. Actually, positive x, I should rotate it around the other way. And we can see it's 1 in the red direction and -2 in the blue direction. And that gives us our point of intersection over here. Now, what I want to really do is focus on what happens to these planes as we work through the system of equations. Okay, so I'm just going to change the matrices step by step as we had done in solving the problem. All right, and the first thing I did was I switched row 2 with row 1. Okay, so I'll just put the 1, 2, -1, and 3 up top. All right, and then this row here, I don't want to have the same thing twice here, so this will become 2, 3, -2, and 6. All right, the bottom equation stays the same. It's still the same 3 planes. It's just the order of red, green, blue has changed. Okay, the red and green switched. So now, what did we do in the next step? In the next step, we had adjusted row 2 and row 3. So in row 2, this would become a 0 after we subtracted twice row 1, -1, 0, 0. And we subtracted 5 times row 1 from row 3, and it became a 0, -12, 5, -10. Okay, now let's see what happens here. The picture doesn't look quite as messy now. Okay, we now have 3 equations that aren't quite as bad. Let's try to figure out why they're not quite as bad, right? The reason they're not quite as bad is because we have 0 in the x column. Okay, so that means 2 of the planes, the green and blue, the second and third plane, it always goes red, green, blue, are parallel to the x-axis, right? So the red axis is the x-axis. You can see that the green plane is right on it, okay? Now the blue plane is parallel to the x-axis. It kind of cuts down below it. If we will kind of look at it sideways there, I've got to turn it a little bit that way. And you can see it'll never touch the red axis, okay? It cuts through the green and the blue axes, but it never touches the red axis. So it's parallel to the x-axis. So 2 of those planes are now parallel to the x-axis because we've eliminated the x variable, right? Let's keep building on that idea. If we go down another step, all right, we did 2 things. First of all, we just multiplied row 2 by -1. So that just became +1, okay? And then we took row 3 and we subtracted 12 times row 2 from it, and we ended up with, let's see, we ended up with a 0, 5, negative 10. Okay, so that's where we ended up in the next step. Let's graph that. It looks cleaner still. Okay, now why is that? Let's look at the blue. Remember, blue is the third one. We now have a plane that is, you can see in the third row, we have zeros in the X and the Y direction. So that means we're parallel to the XY plane. Okay, so the blue axis is parallel to the XY plane. Remember, X is green, X is red, Y is green. So where the blue plane is parallel to the XY plane. All right. In fact, the XY plane is shown in this light gray, and you can see how it is parallel to that. Right. Then we go down to the next step. In the next step, we started knocking out some of the other elements here. Oh, okay, well, in the next step, we just changed this to, we divided the third row by 5. So that became 1 and a negative 2. We'll see that doesn't really change the picture. Okay, it's still, the third row is parallel to the XY plane. But the next step after that, we added row 1 and 3 to eliminate the negative 1 in the Z column of row 1. And so we ended up with a 1, 2, 0, and we had a 1. Whoops, not, go back, and a 1. Okay, and so if we graph this now, look at this. Okay, the blue plane still parallel to the XY axis. Oh, and we can notice the green plane, all right, has no X and no Z, so that's why it is parallel to the XZ axis. All right, so the green plane is parallel to the XZ axis, right? But the red plane, that would be the first row, is now parallel to the Z axis, but it has X and Y values. Okay, so it's a line in the XY plane, but it's parallel to the Z axis. So you can see how that red plane is parallel to the blue axis. All right, if we look at it from above, that's the XY plane, we see it makes a line, the red plane, you can kind of see there is making a line in the XZ axis. So there we go. So it's doing all the things we would expect it to do. Now the final step, we subtracted twice row 2 from row 1, and we ended up with another 0. And we kept a 1 in that column. And let's see, we subtracted twice row 2, so we ended up with this. And if we graph this now, look at that. The messy diagonal graphs, let me get rid of the XY plane, okay, now meet very, very nicely, okay, where each one of these planes is parallel, each one of the red, green, and blue planes is parallel to one of the axes planes, okay? So the first plane is parallel to the YZ plane. So the red is parallel to the YZ plane. Okay. The green is parallel to the XZ plane, right? And the blue is parallel to the XY plane. Okay, so in the end, we end up with 3 planes that are all perpendicular to each other. Okay, red is perpendicular to green. Red is definitely, if we look at it this way, we can see red is definitely perpendicular to blue, and green is definitely perpendicular to blue. So they kind of come together like the walls come together in the corner of a room. Okay, so we've simplified. We started with planes that were skewed in all directions, not parallel to any of the axes. And by the end, each one of the planes ends up parallel to one of the axes planes. All right, and so we get this nice squared out set of matrices, and that corresponds to the very tidy solution: x equals 1, y equals 0, and z equals -2.